Hello everybody and welcome back to The Science of, the show where I take a look at the science behind your favourite game shows and more. Today, we're taking a look at the dark and depressing world that is The Last of Us. Seeing as The Last of Us is finally coming to PC after almost 10 years to the day since the original game released on the PlayStation 3, and the HBO series wrapping up very recently, it's as good a time as any to take a look at the science behind one of Sony's biggest franchises. Taking place in a post-apocalyptic America, The Last of Us is the story of Joel, a smuggler tasked with escorting Ellie through a dangerous world in an attempt to find safety. Throughout the world of The Last of Us, you can find all manner of threats, ranging from hostile humans to cannibalistic creatures called the infected. The infected come in all shapes and sizes, and are spread by zombie rules, with the pathogen being spread through direct contact with infected individuals, whether they be alive or dead. And a startling transformation takes place over the next few days. Seemingly, the only exception to this rule is Ellie, who receives a zombie bite from the infected and yet doesn't change, even after a pretty long amount of time. These creatures are called the infected. They are by all means infected humans, but infected with what? That's what we're going to take a look at on the science of today. We're going to take a look at the science behind this infection, and then going from there, we can make some theories as to why Ellie might be immune to it. Through recordings, we find that the source of infection in The Last of Us is a mutated strain of cordyceps unilateralis, a fungus that attacks the brain of its host, and as a result is able to alter their behaviour. This fungus is a very special species of fungi native to tropical countries like Brazil. It commonly infects the carpenter ant, implanting through its head and spreading throughout the insect's body. After the fungi enters the carpenter ant, the cordyceps propagates and fungal cells are found within the host's brain. Once the fungal population gets big enough, it secretes compounds and takes over the body's central nervous system, which enables it to manipulate the ant's behaviour. In humans, I imagine this process would be fairly similar, with the fungi releasing two main compounds, sphingosine and guanidinobutyric acid, both of which are known to be involved in various neurological disorders. It's also possible that the chemical compound hypoxanthine might be crucial in the fungi's ability to control the ants. Over the course of a week, the cordyceps fungi is able to take complete control over the ant, causing it to leave the safety of its nest and climb to a height of approximately 25 centimeters in an area with suitable humidity and heat for the fungi to thrive. At this point, it forces the ant to stay put and continues to grow until it produces a bulbous capsule full of spores. These spores will go on to infect more of the ant's colony, with the cordyceps taking the ant to leaves that typically hang over the foraging tails for the colony, providing a great amount of prey for the cordyceps to infect. Whilst in the real world this zombification only causes one kind of sort of metamorphosis, in The Last of Us we see a wide variety of different zombie types caused by different stages of the infection. The cordyceps host will go through 4 stages of infection, with their bodies slowly mutating into one of the 4 subgroups of infected, called runners, stalkers, clickers, and bloaters. That is, unless you're Ellie. And each of these stages of metamorphosis has distinct qualities inspired by real-world fungi. Their names give a pretty good idea as to how each of these groups are specialised for their job. Runners are people who have been recently infected and tend to form packs that dash at any prey. Whilst fungi tend to spread very slowly, you could liken the packs of infected to the large clusters of fungal spores that mushrooms will often use to spread around. Stalkers tend to be much stealthier, latching onto walls and hiding from prey in the dark in order to keep the element of surprise. The reason they have to latch onto these walls is in order to gain some kind of sustenance and nutrients to keep the stalker alive until prey walks by, where the lurking infected will suddenly strike. Whilst fungi can be planted in damp soil and survive fine, they can also grow in walls, but if you want that, for whatever reason, they require a humid environment. You see, this humidity is required for most fungi to produce their fruits. Mushrooms have no skin, so moisture is lost very easily, meaning that they have to be kept in a high humidity environment to avoid water loss. Clickers have fungal growths all over their body, resulting in them losing their eyesight and requiring a clicking noise for echolocation of prey. Now of course, fungi don't have mouths, surprise surprise. And whilst cordyceps infected carpenter ants will lose a lot of their senses whilst they're taken over, fungi aren't well known for making a lot of noise. In fact, the opposite is true, with numerous studies being conducted to see how effective fungi can be as a sound absorber. This came as a result of trying to find an environmentally safe replacement for the minerals and synthetic foams typically used for improving a room's acoustics. These biomaterials are 3D printed into desired shapes, and they've been found to work pretty well as sound insulation thanks to fungi's open cell walls and porous structure. Bloaters are large, slow infected that lack sight. Their main threat comes from their ability to tear off fungal layers from their body and throw sacs containing high amounts of mycotoxin. Mycotoxin is a toxic metabolite produced by all manner of fungi, that is, oddly enough, lacking from the cordyceps fungi. Fungi are able to produce mycotoxin when a fungus grows in human or animal foods. These toxins are absolutely lethal to humans and are often causes of food poisoning, as well as other issues including cancer and neurological disorders. These toxins are also commonly a byproduct of fungal spores, which might explain how the cordyceps in the show is able to take out humans, by weakening their immune system first with the toxin before attempting to produce a colony inside their nervous system. But did you know? The use of Ophiocordyceps unilateralis in The Last of Us was inspired by an episode of the BBC documentary series Planet Earth. Naughty Dog developers created the idea for the cordyceps brain infection after they were inspired by a BBC documentary Planet Earth titled Jungles, narrated by Sir David Attenborough. In the episode, it features an infected ant being killed by the Ophiocordyceps unilateralis, as well as showing a variety of other insects and arachnids that were killed by different species of fungi. So now we know that these zombies are the result of a fungal infection, but that still raises the question, why is Ellie immune? Because from all I can tell, all the fungi has to do is get into your head and then bing bang boom you're an infected. Well, from the Last of Us series, we see that Ellie's immunity is sort of an inherited immunity, with it being the result of a cordyceps infection being passed on during pregnancy. Already having cordyceps in Ellie's system, resulting in them acting as a kind of chemical messenger that makes the regular cordyceps fungi think that she's already been turned, despite being perfectly healthy. But in the real world, we don't need this kind of innate immunity to the cordyceps virus. Why aren't humans at any risk from this fungal fiend? In fact, we've had all kinds of bacterial and viral pandemics over the years, why haven't we managed a major fungal outbreak yet? Well, these are both answered pretty easily. First of all, fungi, unlike most viruses and bacteria, don't require a host to exist. They're perfectly happy just being in some damp hot hole. As well as this, fungi are generally not spread from human to human, which would limit their rate of infection even if they did start to infect on a larger scale. But still, why can't the cordyceps even attempt to take on a human in the real world? Well, as it turns out, again, the answer is very simple. The cordyceps fungi can't infect any fish, amphibians or mammals. And why? Well, as it turns out, we're just too hot. Most species of fungi can simply not survive the high temperatures of the warm-blooded body. Interestingly, only a few hundred species of fungi out of the almost 5 million in existence can cause infections in humans. This is a result of the stable body temperature of 30 degrees Celsius, as well as the human's body's natural immune system, which can do a great job at eliminating fungi. Insects are able to be infected far easier as they have a much more rudimentary biology, with a lower body temperature and a much simpler set of internal organs. Given evolution, it probably took millions of years for the cordyceps fungi to be able to infect an ant, and it will probably take a few million more in order to even begin surviving in a human host, let alone controlling us, as seen with the infected in The Last of Us. So there we go. Whilst The Last of Us is still way more realistic than your average zombie show, game or loaf-headed series of collectibles, there are still a ton of inaccuracies in the way it shows the spread of the infection, plus the whole fact that cordyceps wouldn't be able to infect humans even if it wanted to. But this series isn't done by a long shot, with Series 2 of the HBO series telling us the story of the game's sequel, and I can't wait to see how it turns out. If you want to see me cover more of the science behind your favourite Sony series, then make sure you comment down below telling me what your favourite PlayStation franchise is. The best comments will be shown at the end of the next video. And if you want to see me cover more of the science behind fungal fiends, then take a look at a video here where I take a look at the science behind Yoshi's fuzzy enemies, or if you want to see me cover some other microbial menace, then take a look at a video here where I take a look at the science behind a Zerx from Stray. Either way, don't forget to like this video and subscribe to the channel if you want to see me talk about more of the science behind your favourite game shows and more.